All right, let's jump right into this explainer and look at an absolute mega structure. We're talking about a marvel of engineering that literally conquered a wild river and built the modern American Southwest. The Hoover Dam is a true engineering marvel and an absolute must-know topic for your geography studies, perfectly showcasing the ultimate example of human-environment interaction. Here's our roadmap for today. We're going to meet the Hoover Dam, look at how it tamed the wild Colorado River, dive into the epic construction effort, see how it powers the Southwest, and finally, discuss the looming climate change threat. So, Section 1, meet the Hoover Dam. Standing at a massive 726.4 feet tall, from its foundation rock all the way up to the roadway on its crest, this concrete behemoth is basically the equivalent of a 60-story skyscraper wedged right into the volcanic rock of Black Canyon. When they finished it back in the 1930s, it was the highest dam in the entire world. Oh, and its base? It's as thick as 2 entire football fields laid end to end. And get this, it contains 4.36 million cubic yards of concrete. To put that absolutely massive number into perspective, you could take that exact same amount of concrete and pave a standard 2-lane highway stretching all the way across the entire United States. I mean, literally from San Francisco straight to New York City. This is what we call an arch gravity dam, which means the unimaginable weight of all that water is held back by both gravity pulling down and a horizontal arch action pushing out into those solid canyon walls. Moving on to Section 2, taming the wild Colorado. Now, you might be wondering, why go through the trouble of building this massive fortress out in the middle of a desolate desert? Well, make sure you get this down for your exam notes. The dam was built for 3 main reasons: to stop the devastating, unpredictable flooding of the Colorado River, to secure a reliable supply of irrigation water, and to generate some massive hydroelectric power. Basically, the dam caught those wild spring floodwaters melting off the Rockies, stored them up for crops, and passed them through giant turbines to generate clean, non-polluting electricity. And honestly, that electricity actually ended up paying for the dam's own construction. Looking at this vast shaded area of the Colorado River Basin, you can see exactly why harnessing this water was quite literally a matter of survival. 7 different states had to sit down and cooperate to share this one vital resource. Without regulating the mighty Colorado, large-scale farming, and the explosive growth of cities in this really harsh, arid region, it would have been completely impossible. All right, Section 3, the epic construction effort. So starting out as the Boulder Canyon Project back in 1931, this whole idea was heavily debated. It was actually first called the Boulder Dam in 1933. Amazingly, despite some truly brutal working conditions, it was completely finished 2 whole years ahead of schedule in 1936. Then, in 1947, it was officially renamed the Hoover Dam to honor President Herbert Hoover, who fiercely championed the original 1922 Water Compact. Because of the sheer mammoth size of this undertaking, no single company could handle it alone. It took a massive consortium called 6 Companies, Inc., who bid the equivalent of $674 million, by the way, directed by the Bureau of Reclamation's brilliant chief engineer, Frank Crowe, to pull this whole thing off. We are talking about over 21,000 men working in an unforgiving, 125-degree desert, doing incredibly dangerous manual labor. Think dangling from canyon walls just to blast loose rock with explosives. Yeah, pretty intense. And the result? Well, the finished arch-gravity dam completely transformed the entire canyon. It trapped the river and created America's largest man-made reservoir, Lake Mead. Holding back over 28 million acre-feet of water, this stunning blue lake basically acts as a giant geographical battery. It stores up all that potential energy and life-giving water for exactly when the super dry Southwest desperately needs it. Which brings us to Section 4, powering the American Southwest. The energy from this engineering marvel literally built the modern Southwest. It powered millions of homes and allowed these incredible desert oasis cities like Las Vegas to just explosively rise right out of the sand. Look at the staggering contrast here. On one side, you have the raw, brutalist concrete wall of the dam housing 17 massive turbines. On the other side, the glittering, vibrant neon lights of Vegas. Without the dam's reliable water and cheap hydroelectric power, sprawling urban centers across Nevada, Arizona, and Southern California, they simply could not exist. But it's way more than just neon lights. The dam's water irrigates over 1 million acres of crucial farmland in California and Arizona. That produces billions of dollars in crops, meaning the Hoover Dam makes a huge chunk of the produce grown in the United States today entirely possible. It serves nearly 20 million people across the basin, and as a bonus, has turned Lake Mead into a booming recreation area visited by millions every single year. Now, as you can see, the dam's absolute success triggered a massive population boom in the lower basin states. Notice how those lines climb relentlessly upwards between 1985 and 2010. But, as we know in geography, every environment has a carrying capacity. And this massive population explosion, it created an insatiable thirst for the dam's water. And that leads us to our final part, Section 5, the climate change threat. Here's the harsh reality. As population and agricultural demands have just skyrocketed, we've started using way more water than the Colorado River can actually replace. We've essentially been gambling with our water supply for decades now, pulling out massive transfers for Arizona, California, and Colorado. And it's far, far more than the yearly mountain snowmelt can ever replenish. So when you combine decades of climate change-driven severe drought with this absolutely massive demand, it means Lake Mead's water levels are dangerously dropping. This threatens both the water supply and the dam's ability to even generate electricity. Basically, if the water level drops too far, the dam becomes what's called a dead pool, which means water can no longer flow through those massive turbines to generate that vital electricity. So I'm going to leave you with this somewhat chilling thought. As the Southwest faces unprecedented water cuts, can humanity find a way to save the very system that allowed us to conquer the desert in the first place? Or will the mighty Colorado River eventually just run dry? Keep those questions in mind as you review your notes. Thanks for joining me on this explainer, and keep exploring.